It will be an age of abundance, the likes of which people have almost no one has envisioned. It'll be something special. Tesla has a track record of having made many great products, and we're going to make many more future great products. And we're going to scale up production, and I think we've demonstrated a level of innovation that is extremely rare. Certainly by far the most innovative company in the car industry.
From the early days of leading Tesla, Elon Musk has made it clear that Tesla would never be just another EV company. What the industry deemed impossible or outright crazy, Elon Musk set out to achieve. That's why Tesla has rolled out a series of bold, unconventional products like the Cybertruck, Tesla Optimus robot, Cybercab Robotaxi, Cybervan, and now the Tesla flying car, the next product to prove Musk's vision. This project has already been leaked as part of the product lineup and manufacturing plans at Giga Texas. Of course, Tesla isn't the first to tackle a flying car project. Companies like Klein Vision have unveiled their own flying car prototypes, but at a steep price. Yet Tesla claims it can produce a flying car for just $6,780 by leveraging components from its EVs, significantly cutting R&D costs. That means it costs only 1/16 of a Model 3. Sounds insane, right? And how can Elon Musk pull it off at a $6,089 price tag? Let's dive into the production line now. Welcome to Tesla Car World. Honestly, when you first hear the term flying car, it sounds like a joke, something completely unrealistic. And if you weren't watching this video, we're pretty sure most people would dismiss it as mere clickbait. However, this is a type of vehicle that's been gaining significant attention in recent years in an effort to revolutionize how we travel. Much faster than driving a car, yet far less complex than flying a plane. Before bringing this project to Tesla, Elon Musk likely recognized the potential from pioneering companies, as our research shows that this idea was first pioneered and quickly brought to life by Klein Vision. To give you a clearer picture of the Tesla flying car project, we'd like to briefly touch on Klein Vision's flying car, which offers a practical glimpse into how a flying car actually works. Specifically, Klein Vision unveiled a gasoline-powered flying car available in 3 power variants: 280 horsepower, 320 horsepower, and 340 horsepower, comparable to high-end sports cars or performance SUVs. Despite being a flying car, it's equipped with standard pedals and controls like a regular vehicle. The wings are neatly stowed in a dedicated compartment, and the tail folds compactly for road driving. The company claims a maximum safe ground speed of about 124 mph, and with 3 fuel tanks holding a total of 42 gall, it can travel roughly 497 mph on a single fill-up. In car mode, the air car measures about 6.6 ft wide, 19 ft long, and 5.9 ft tall, roughly the size of a Rolls-Royce Phantom. Though the flying car is slightly taller, it's easy to see its sleek, cutting-edge aerodynamic design paired with a composite structure. The front end reminds us of modern sports cars. But what really blew us away is its weight. Just around 1,764 lb. That's almost unbelievable compared to the Phantom, which tips the scales at 795 lb despite similar dimensions. We believe this impressive weight savings comes from the manufacturer's use of specialized materials, stripping away unnecessary components compared to traditional cars and adopting a monocoque chassis design instead of a welded tube frame. But if that 1,764 lb figure is accurate, if you look closely, you'll notice the car's body is smoothly sculpted with elegant curves, much like a high-end sports car, an ideal design choice for reducing air resistance at high speeds. The large windshield offers a panoramic view, especially useful in crowded urban environments. With its low-slung, sporty body, the air car is clearly better suited for smooth paved roads and is not ideal for rough terrain or off-road conditions. Its large dimensions also make it less maneuverable in tight parking spaces or sharp corners. At least that's our take. On the other hand, Klein Vision's flying car is one of the few flying vehicles to adopt a 4-wheel configuration rather than the more common 3-wheel design. This reflects the company's bold future-focused vision. Choosing 4 wheels means accepting higher manufacturing costs and stricter regulatory standards, rather than taking advantage of the more lenient rules for 3-wheelers, which are typically classified as 3-wheeled motorcycles under U.S. law. Moreover, every line on the body and roof appears to be carefully refined for aerodynamic efficiency, ensuring optimal performance both on the road and in the air. When switching to flight mode, The entire process takes less than 2 minutes. An incredibly impressive feat considering that all systems must operate in perfect sync and precision. You simply drive the vehicle to a runway, press a button, and it transforms. During the transition, the wings unfold to a span of 26.9 ft, and the tail section extends backward into its optimal flight position, a process that takes about 80 seconds. At that point, the engine disengages from the wheels and powers a rear-mounted propeller instead. After a quick walk-on check, you're ready for takeoff. According to Anton Zajac, co-founder of Klein Vision's flying car, the vehicle has a stable cruising speed of 155 mph and a flight range of up to 621 mph, reaching altitudes of up to 10,000 ft. The current prototypes have already received airworthiness certification and have accumulated over 170 hours of flight time with more than 500 successful takeoffs and landings. So that's a brief overview of how a flying car built by an experienced company actually works. But what about Tesla's flying car? What sets it apart? The first major difference is that Tesla's flying car is expected to be fully electric rather than powered by an internal combustion engine. Just like with their other products, thanks to advanced battery technology, the Tesla flying car could deliver an emission-free travel experience, significantly lower fuel costs and reduced noise levels compared to traditional aircraft. Batteries are one of Tesla's strongest assets, and leveraging that resource could play a key role in cutting down the cost of producing a flying car. However, a potential drawback lies in the limitations of battery capacity and weight, a major challenge for any flying car, especially given the high energy demands required for takeoff and sustained flight. If Tesla opts for a battery pack that's too large, the flying car becomes excessively heavy. But if the pack is too small, it simply won't deliver enough power for the motors. That's why the only viable solution is likely the use of Tesla's 4680 battery cells for this model. The 4680 cells offer an ultra-high energy density of up to 300 Wh per kilogram, allowing the battery pack to store significantly more energy without increasing its size or weight dramatically. This means Tesla can equip the flying car with enough energy for flight without resorting to a bulky or overly heavy battery. In reality, developing a flying car isn't as simple as slapping wings onto a Tesla EV. It requires groundbreaking advancements in aerodynamics, flight stabilization systems, and most critically, strict adherence to aviation safety regulations. Every component, from structural design to software, must meet rigorous standards far beyond those of typical road vehicles. Although Tesla hasn't officially revealed the design yet, in car mode, the Tesla flying car is rumored to resemble a compact version of the Roadster, optimized for maximum aerodynamic efficiency. As you may recall, Elon Musk once claimed the Roadster could accelerate as if it were flying, going from 0 to 60 mph in under 1 second. The Roadster also features several engineering elements derived from SpaceX, Musk's other major venture. Rather than using traditional propellers like today's aircraft, the Tesla flying car is likely to be equipped with electric jet engines inspired by SpaceX's powerful propulsion technologies, but adapted for electric flight. These engines would enable a more efficient and sustainable journey through the air. Additionally, Tesla is expected to integrate Falcon-style landing technology, allowing the vehicle to take off and land vertically smoothly and with precision. This would give the car better control throughout the flight, and most importantly, ensure safe and soft landings. The lighter a flying car is, the more efficient it becomes. So, it's no surprise that the body will likely be constructed from ultralight aluminum alloys combined with carbon fiber, featuring gull-wing doors and a retractable wheel system that tucks into the chassis during flight mode. With just a press of a button, the vehicle transforms in under 90 seconds. Two multi-joint bird-like wings unfold from within the body, while the rear section extends to enhance in-flight stability. The wheel system on the Tesla flying car is intelligently designed to retract into the body during flight, reducing aerodynamic drag. In car mode, the vehicle is powered entirely by dual electric motors, one in the front and one in the rear, giving it the ability to accelerate from 0 to 60 mph in just 3.9 seconds. In this mode, it functions much like a typical Tesla, featuring autopilot for assisted driving and access to fast charging via the supercharger network. Every Tesla flying car must undergo rigorous testing from crash, resistance to flight stability and poor weather conditions. Finally, securing regulatory approval from aviation and transportation authorities will be no small feat. Current regulations for flying cars are virtually non-existent, and Tesla will need to work closely with government agencies to ensure that the flying car meets all legal and safety standards before it can enter mass production.